Hello and welcome to the Wednesday lecture. Today we talked about the a little bit of graphing stuff, a little bit more graphing stuff, I guess. And I just wanted to make this video. I typically in my classes make videos and haven't been doing it so far. So I want to get into this habit because I know that not only will it help the people that can't make it to class for whatever reason, have a little bit better chance to do the homework correctly, but also if you need a quick review. And I will say, I do want to kind of start this by saying I am never opposed to anybody looking up other videos on these topics. There's a wide variety of videos out there. Most of them are very good, just as good as what I'm doing, or even better. So feel free to do that. I think it's helpful. I think it's always helpful to reach out and try to find more help. And then also, if you ever need to get in touch with me, send a comment via Classroom or whatever, and I'll do my best. And if we have to set up a one-on-one meeting, then we can do that as well. I have some downtime throughout my day that I can find time to do that. So let's take a look at today's stuff. So we talked about how to graph using slope-intercept form and some important notes that I think you should have as far as how to do it. The first thing we want to do is to plot our y-intercept. So the y-intercept comes from the second part of the equation, comes from this -4. So we're putting that on the graph. And then in order to get any line, I need to have 2 points. So I do want to plot another point. Plot another point using my slope. Okay, so the way I'm doing that is I'm taking the number that's multiplied by x and writing it as a fraction. And knowing that a positive slope goes up, a negative slope goes down. This is a positive slope, so it goes up 2 and right 1. So I'm going from this point up 2 and right 1 and putting another point. Now, answering on Edge Elastic just asked for those 2 points. But if I was doing it by hand, I like to keep going, giving me more points, because the more points I have, the straighter my line can be, especially when I'm trying to freehand it, or even if I was using a ruler. Okay, to try to give myself the straightest line I can get. So without, I guess, writing it, I already did it. Step 3 is going to be to graph the line. Okay. So moving on to standard form, and if you were still writing those down, remember it's just a video. You can pause it, rewind it. Not really rewind, but click back and get what you missed. So to graph using standard form, that's when x and y are on the same side and there's a number on the other side. We used what was called the cover-up method. So if I'm looking at my steps that I follow, I use the cover-up method. And other people call it different things. And it's typically done the same way. You could always use like a table of values. You could do it that way, but I like the cover-up method for one reason. That when I physically, now sometimes I'll do it with, I'll cross it out. I don't really want to cross it out because I want to know it later, so I don't want to make it unreadable, but sometimes I'll just do something as simple as cross that out. Okay, but I'm going to somehow cover up the x term. And the idea of term means the sign in front of it, the number in front of the variable, and the variable. Okay, so the three things. Now, typically, instead of crossing it out, I will cover it up with my hand if I can. I will, put a lot of times on here, if it's small enough, I'll put my little pen cursor over it. But sometimes I'll go fancy and I have something to actually cover it up. So this leaves me with an equation, and usually I'll write down that equation so it looks a little bit better. Because technically, when that 2x is there, this is minus y, but I like to think of that as a negative y. And what I want to do with that equation that I write is solve that equation. So solve that remaining equation. Okay. If I solve that equation, negative 1 is being multiplied by y, so I'll divide y by negative 1, or I'll divide both sides by negative 1, and I get that y is equal to, negative 4. And that solved equation gives me my y-intercept, so I will plot the y-intercept. Okay, so I plot that negative 4 as my y-intercept. Okay, now at this point, I'll repeat the same thing, but I'll cover up the y term. So I will cover up the y term. And now I kind of want to repeat steps 2 and 3. But with a different variable. So now I'm looking at an equation that says 2x equals 4, and I want to solve that equation by dividing by 2 on both sides. Gives me that x is equal to 2. And I'll plot that x-intercept this time. It's not a y-intercept, it's an x-intercept. So then looking at my original equation, this 2x minus y equals 4 gives me this line right here. And it's a little bit harder because I only have 2 points. And if I was doing it by hand, sometimes what I'll do is I'll use those 2 points to kind of make a modified slope. It's just a slope from 2 points that I was given. It's not always going to be the simplest slope there is, but it is still a slope. It still gives me a direction that I can follow. And if I can put that on there again to give me another point, I will. This one goes up 1, 2, 3, 4, and over 2. 1, 2, 3, 4, and over 2. And it can give me another line that just makes freehanding, or even working with a ruler, but putting a line on there, that's a little bit easier to do. This one's got a little curve to it. It shouldn't. It should be straight. We can kind of fix that down here. It's right in here that was kind of tough. Okay. But really 2 points is enough to graph your line, and especially if you're working on a computer with a straight line tool, which mine does have, but my straight line tool is a little bit different in that it's only a line segment tool, and it only puts a line in between the 2 points. I want to know that thing all the way through. The edge elastic line, once you click those 2 points or click 1 point and then drag your second point to where it needs to go, it will give you your line and you'll be good to go. Okay. Oops. I guess as it's kind of step 5 is to repeat those 2 steps. And then my last step was to graph the line. Okay. Then we came across a problem like this that says x is equal to -1. And my question is, what do I do with this? What can I do? There's only one variable. There's no y. All my other equations had an x and a y in it. So my best advice for a problem like this is to look at the equation and actually say it. Okay, don't just, and I urge you to do this with almost everything in math, is to actually say what the problem says. Say it out loud. You might seem weird sitting at home, sitting at your computer, doing your homework, and say, x equals -1. Or even x is equal to -1. Or even the x value is -1. I know it seems weird, and I seem weird, but I'm in an empty room. It's still weird. I'm talking to myself. I'm good with that. But what we want to think about is, when does the x value equal -1? Well, if I look at this other graph, and this is just the same type of graph, I just, instead of coordinate crossings everywhere, I have all their actual x and y values. So it's a little bit different, but it's kind of nice, because I'm looking for wherever the x comma y coordinate, where the x value, the first number, is -1. Well, that happens here, that happens here, it happens on all these places, right? So if I think about that, I mean, I could kind of graph it on here, but it would look kind of weird. So I'm going to bring that other graph back up. Let's see if I can do this quick. Nope. That one? Aha, that worked. All right. So if I bring this graph back up, I'm thinking about all the values where the x value is -1. That happens here, here, here. And so this line that we get is actually a vertical line that goes through -1. Goes through x equals -1. Okay. So even though they didn't give me two variables, they only gave me one variable, I can still graph a line. It's still a line that makes sense. Now let's think about this in a couple different ways. Okay. Let me give you another reasoning behind this. And this one's a little bit different, a little bit tricky. But before we graphed lines in 2 dimensions on an XY graph, we graph lines on number lines. And it may be a while ago, or we didn't graph lines, I guess, but we graphed on number lines. Okay? Where we said, yeah, here's 0, here's -1, here's -2, and so on, right? We had all these. Well, really what we were doing is we were looking at the x-axis. And if you looked at this line right here, and you said x is equal to -1, you would just get that point. Well, the xy axis to the right is just a vertical pulling of that horizontal graph. If we just think about, I always think about, like, I have maybe a rock stuck in my shoe, or maybe the tip of a marker stuck on the bottom of my shoe. And if I drag that, that's going to smear this, that's going to drag that line vertically, and that's what we're going to end up getting. That's the same vertical line that we have right here. Same thing as if I pull that horizontal x graph apart, I end up with a vertical line at that one point that was already marked. That one point gets stretched out into a line. So that's another way to think about it. Is it the best way? I don't know. I can only come up with so many ways. But that's how we get that vertical line, x is equal to -1. Now, along the same thought process, I could look at a line like y is equal to +3. And where does that line go? Well, thinking kind of the same way, it has a y value of -3, and it's looking for every y value that is -3. Let me pull that other graph up really quick. So I'm looking for every y value that has a that has a +3. I think I said -3 before. But these ones, the y values are all -3. Gosh, I did it again. Are all +3, right? Those all have y values that are +3. So that line, instead of being vertical, even though it has the variable y, it's looking for all the y values that are +3. So if we go back to our original graph here, more of a standard graph, we're looking for y values that are +3. That's all of these ones, okay? And it's also all these other ones in the middle, right? Every single point along this horizontal line has a y value of +3. So our graph on this one would be a horizontal line going through y = 3. Okay. So these are two differing problems, right? One says x = -1, one says y = 3, and it's pretty common that students can graph both of them if they run into a problem that has both of these lines on them, and they can do it pretty well. Where the trick comes in is if I only have one of these problems, how do I know whether it's horizontal or vertical? Okay, and that is the trick. That is the tough part. The tough part that you have to deal with. I would always encourage you, think about this graph, and sure, we never see a graph that looks like this, but think about it and use it to your advantage. And I don't recommend anybody else try to make this, especially by hand. It's kind of a pain. I did this on a computer. And it's helpful. I find it very helpful at times that yeah, sure, we see this graph, but we never, or we see graphs that look pretty normal, right? They just have lines everywhere, and they might have the numbers going up the y-axis and along the x-axis, but we never really think about all these other coordinates as their true coordinate points. We just think about them as, well, that's an intersection of two places. It definitely helps if you think about it this way. Okay, that can help you with the horizontal and vertical line concept. Okay, so that's it for today. Hope that helped make sense. Good luck on your homework, and we'll see you next time.